Good morning, everyone, fellow project managers, PMPs to be, those of you who are already certified. I want to thank you for joining us this morning. This is the IAC Training Blitz. I know some of you saw this and may have been a little bit hesitant to join, but infrastructure as code is a topic, cutting-edge topic that PMs need to know a lot more about. So we've got our in-house expert. He's a certified Scrum Master, Lean Six Sigma Black Belt, has been in computers for a long time. It gives me great pleasure to introduce our speaker for today, Paul Lewis. Over to you, Paul.
Hi. Yes, my name is Paul Lewis. I've been a technical project manager for over 20 years. Right out of college, I started fixing computers to make sure my technical chops were up to par. I continually keep my skills up to date by doing outside project work, always in a technical capacity. Six Sigma Green Belt. I'm a Scrum Master, and also now I'm a delivery manager within an Agile program.
Awesome. So, Paul, can you give us a little bit of background about what a delivery manager is before I talk about Praizion?
Sure. A delivery manager really is someone who helps the delivery of a Agile project, really is to handle most of the escalations that occur. So basically, I'm known as the fixer. So when things aren't going right within an Agile program, within a sprint, I'm usually called in to help run interference and work with the customer and to facilitate any outside activities that need to happen within a Scrum that may be of an emergency nature. I'm part of the leadership team of the program. I work with the program manager and the technology delivery officer.
Gotcha. So it's more of an agile environment, not hardcore Scrum, where there are certain roles with names defined. And for example, let's see, what's a common role in the world of Scrum that you guys don't do, or do you do all of it?
We do all of it, depending on we have software development teams that really are more Scrum than, let's say, infrastructure,
Okay.
and that's primarily because of the long lead times for certain items of infrastructure. Especially if you're building out a data center, you can't do things within a sprint because the servers take a lot longer to get in.
That's true. Yeah.
So that's really the difference. So what we do is we take the principles of Scrum and put it within the Scrum teams, and depending on how the application development team, how far along they are in their Agile journey, we actually more times than not integrate with them.
Okay. Gotcha. Okay. Well, thank you, Paul. Well, Praizion is the company behind this event. Praizion has trained various organizations and government entities worldwide. And most of the time, we're used to delivering things in the line of project management, Scrum, Agile, that type of stuff. But today, we're going a little bit deeper into a little bit more of a technical world of what exactly it means when you say infrastructure as code. So, Paul, over to you, and just help us unravel this mystery that is a mystery for many people.
Hi. So if you're looking at infrastructure as code, pretty much there is these three pillars of infrastructure as code. It's installation, configuring, and connecting. And there's different tools that are used for building this out, and you'll probably see these talked about, like TERRAFORM, Chef, Navigator, Jenkins, Inspect, and Git. These are all the components. I'm going to go over a few of these today. This is hours and hours of information here, but at least give you a high level understanding of how these all work together to deliver. Typically, you'll be partnered with an engineer who will actually do the code, but you really need to understand what's behind it, because what's happening now is a lot of these pieces here you see can be delivered now within hours, not days and weeks and months like it used to, because everything's virtualized now with Amazon and Google and with Microsoft Azure. All of the cloud is now available for most companies, and even companies that are larger size that have the large bits of infrastructure, big, huge data centers, they are also feeling the pressure to create their own private clouds. So this is still used within those private clouds, because this is what the application development community wants. And to be honest with you, it has really shortened the lead time to deliver new products to companies. So looking at this and how the technology has changed, I can tell you that 5 years ago, projects typically took us a year or two to deliver. Now they get done from beginning to end within 3 months, and these are multi-million-dollar projects and lots of infrastructure.
Wow. Wow. Can you give us some sort of real world problem statement or project high level charter to understand what exactly this is all about? So for people
Sure.
who are not that technically deep, they're wondering, is this the installation of a server, or is it installation of a data center, or what
This is
is it?
everything. So basically what this is, this delivers the server and the environments. So let's say you have a requirement from a customer. They want to build a new application that has a SQL backend
Mhm,
plus a couple servers and then a web front end with Java.
mhm.
This delivers all of it at
Mm.
once
Wow.
within hours at the most. Um, Usually it's within minutes. But a really good way to kind of see how this kind of works, you can open up, and most people have an Amazon account already.
Yeah.
You can open up and actually create your own servers on Amazon for free. Um, and you can see how quickly it takes to spin up a server with SQL on it. It literally takes 5 minutes.
Wow.
And then you have to do some configuration afterwards. But as you can see with the Navigator piece here that we use, it does that for you as well. Creates the load balancers, the DNS, the database, the servers, and Java. So a lot of this stuff is now anybody can do it. When you really need a Scrum Master, PM to help, it's typically a lot of infrastructure. So if you're building
Mm.
multiple big servers, but you still can do it. We're delivering right now like a 40 terabyte Oracle database. We'll have 20, 30,000 simultaneous connections, all via infrastructure as a code. And that's what the difference is now compared to what it was even 6 months ago or a year ago. And I can tell you, looking through a lot of the postings for job wants, they're all talking about this. They're all talking about Jenkins, Experience, Terraform, Chef,
Mhm.
with some Git and Navigator. And this is what we use. And there's a lot of others as well.
Cool. Cool. Okay, that's helpful. Thank you.
So infrastructure as code delivery package, this kind of goes through how it works. So when you're designing this piece here, we call it SLD as a standard engineering term. So it's a systems level diagram. So we figure out what it is that you want to build at a logical level, databases and connections and so on. You then feed that into JSON, and you work with clients to determine the solution and generate JSON input for provisioning code. And that's another piece that we do. And because the servers now are not physical servers and very few are built now, I can tell you that when I started, we could build physical servers within 3 months. Took us 3 months. Everybody knew what they were doing. When I provision a physical server now, it's so rarely done. We always have problems because people don't remember how to do it anymore. And we're talking about a 300,000 employee company that I work for, because we have our infrastructure is all virtual. Everything is using VMware to build infrastructure. Hardly anybody needs physical servers anymore. And that's just the way it is. If you look at Amazon, they design their own physical servers to handle the virtualization they need. So did Google, and so does Facebook. So this is a industry-wide transformation from I'm going to buy a server and I'm going to put this on here. We don't do that anymore. No one does it anymore unless you're a very small company. And even those I wouldn't even say to do it because it doesn't make any sense financially. Everything is virtualized. So when you're looking at building it, you put it in JSON, you do some scripting, and then Terraform through the API creates your infrastructure. That's infrastructure as a service or a program as a service. That's what those things are. I covered that earlier in another slideshow that we did earlier. But anyhow, that builds the servers, the containers, and the databases. And then the second day, you run Chef, which has the actual application settings. And then it creates the load balancers, creates all the names, and then does all the firewall. So as you can see from here, you can build an entire infrastructure nuts and bolts from beginning to end in about a day or two at most. And this would be for a very complex application that you're building that would have lots of DNS entries to make, some load balancing, some firewall entries. If you're building something that's internal, we can spin up now disk and servers within an hour, and then load the operating system's already done for you. Everything is done. The developers can take it and start developing. Because of the way that IT is now, there's the tolerance for taking a long time to build infrastructure just isn't there. Developers want their infrastructure right now. They need partners, and they need to know how to navigate this whole piece here and to size it appropriately. And that's kind of where we would come in, which is why I'm really going through the nuts and bolts here so you understand how this affects you as a PM or a Scrum Master. So vRealize is a piece here for VMware. Infrastructure as a code. It leverages the best practices for capacity models. So this is for a very large environment. They have the ability to combine tactical with strategic. That way that you can build something very quickly, you need it right now, and also be able to build something that you're going to use for years from now and you take a little bit more time to build. Because we have both instances, and that happens in the real world. Sometimes you need an application quickly. You just landed a client. We need to build this application right now for them, and you can do it. But if you want to build something that is a new client coming in, but you have a long lead time and want to look at developing something for the future and further capacity, then you would go ahead and do that. There's additional providers for Terraform, and APIs will expand this capability. And then consistent source code management, quality assurance, configuration management, API-enabled architecture, all is built into all these infrastructure as code facilities. So like Amazon is done this way. Microsoft's done this way. Everybody's kind of using the same tools. Microsoft is a huge contributor to this. So things have changed dramatically within Microsoft. As a matter of fact, I would say that they are at the forefront now instead of being behind of the Red Hats and the Linux side and the open source. Microsoft is actually the top dog right now. They actually bought GitHub. They're contributing a massive amounts. Most of these pieces here, Microsoft has done a ton of work, both on the Unix and the Microsoft platform side. So there's something to keep in mind. This is not just huge environments. Even if you had a customer with 100 employees who wanted to use Amazon Web Services or Azure, this is all pretty much the same. There might be different tools, but the boxes are the same. So I'm going to go into Terraform. This is the big one right now for configuration. You use this to build, change, and version control your infrastructure. This is really the heart of infrastructure as code. Is a tool to manage the virtual life cycles, AWS, VMware, etc. All those, and it supports and it's a tool to manage supporting services like DNS and email. So again, Terraform does a lot of things, and it really depends on the company you're working for how much they use this compared to another tool. There's no silver bullet. Everybody just takes pieces of these that fit best with them. So it's just good to have a good understanding what Terraform is. You also can manage system services like MySQL and PostgreSQL. Configuration files could be HCL or JSON, which are again those middleware pieces that actually do the scripting. And it was created by HashiCorp Variant and is written in Go. I don't know those languages, but it's just good to know that what it's written in. Sometimes I find for myself, having a little bit of technical background keeps the engineers honest. So what does it do for us? It talks to multiple cloud infrastructure providers. It doesn't just do one or the other. It does AWS. It can talk to all of them. It just really depends on the infrastructure that they have and what they allow. So it's something you would have to check out. Most like your engineer assigned would be able to do that, but it's something to keep in mind so you know when they're talking about this, that this is something that they understand. And it's Express. It's an API agnostic language, so it doesn't really matter what it is. It can talk to all of them. So change infrastructure, will apply incremental changes, updates, allow you to increase RAM, increase disk dynamically. So again, the benefits of this type of system and the virtual world is that you can make those changes on the fly. You don't have to have a guy run out there, pop open the machine, have tons of downtime, add RAM or disk. It's dynamic. It can happen right in the middle of a transaction. Most times don't even need a change for it. It's that quick. And then when you're done with it, you can get rid of it. Again, that's another really nice piece of this, is that hanging on to this old equipment that isn't good anymore, you don't need it anymore, it saves a lot of cost, because as soon as it's gone, you're not charged for it anymore. And that's another thing that's really beneficial for these cloud and virtualized environments now. It really does allow you to control costs. So if you need to build an environment really quickly to prove a concept, which happens a lot, demo it to the customer, they say yay or nay, you destroy the old environment. And before, when you had to buy physical equipment, you couldn't do that. You were stuck with it. This really helps you provision and deploy very rapidly, and it really fits into Agile very well for these application development teams, in that you usually can deploy all this, and they can actually put code on it within a sprint. It also allows you to preview the changes before you do it, and as I said, it scales very easily. So if you wanted to build 2 servers or 200, it doesn't matter. This will do all of them equally, and doesn't really take any more time. So some of the variables, TERRAFORM takes variables as input. It's type variables and uses JSON, ACL, or CLI, which is the different input